Hello and welcome to Math 45. This is section 3.1 and we are on page 1. So here goes our online remote class. So for section 3.1, we are going to be learning about functions and function notation. So here's our textbook definition of a function. A function is a relation in which each possible input value leads to exactly one output value. We say the output is a function of the input. The input makes up the domain and the output makes up the range. So just to make sure we have our definitions, we know that the input, let's erase that. So we know that our domain is really our input, which really just represents our x values. Similarly, what we have is our range. That's our output. And that represents our y values. Now, to actually get the big idea of the definition of a function, what this is saying is, hey, one input leads to exactly one output values. And in English, what you can think of as the definition of a function is just making sure that the x values don't repeat. So that's really our definition of a function, if you want to think about it that way. So let's take this definition and put this into practice. So we have 3 different tables. We want to see which ones are functions and which ones are not functions. Well, the input, which is the x value, and the output, which is the y value, we are going to be specifically looking at the x value. We want to make sure that these don't repeat, and they don't. And because they don't repeat, then that means that this table is definitely going to represent a function. Now, for the next one, we look at our input. We don't necessarily look at our output, but looking at our input, again, we see that nothing repeats, therefore this is a function. However, when I start looking at the last table for my x and my y, I see that 5 is repeated in my input. And because that repeats, then we're going to have to say that this is not a function. So because the domain, the x values, had 5 twice with different outputs, therefore it is not a function. Now we're going to determine whether or not things are functions looking at the equation. So really you want to pay attention to the exponent on y. So here is y. So the exponent on y is 1. This is also a linear equation. So really this is definitely going to be a function since none of our x values will be repeated. Now for part B, let's look at our y value. See this exponent? Well, we have that the exponent on y is now 2. And this is actually going to represent a parabola. But this is either an opening left or an opening right parabola. So here, if I put in a particular y value, it can give us 2 different x values. Therefore, this is not a function. Definitely not a function. Well, when I look at this one, again, the exponent on y is 2. It's going to be one of those parabolas, or actually it's x squared and y squared. So this is actually going to be a circle of sorts. But either way, just think about it just as the exponent. Therefore, it is not a function. And here we have the exponent on y is 1. Therefore, this is definitely going to be a function. Okay? So you really want to pay attention to the exponent on y. Now, another way to tell if something is a function is by using something called the vertical line test. I like to refer to it as the VLT. Remember, a vertical line goes straight up and down. So if you can draw a vertical line on any graph and it crosses at most once, it's a function. If it crosses more than once, then it is not a function. For example, here, you see this vertical line in red. So maybe I'll just point that out. This is my vertical line. I can see that it only crosses my graph once. Therefore, I definitely know that this is going to be a function. Versus the second graph, I see that the vertical line crosses it twice. Because it crosses it twice, therefore is going to be not a function. And that last one, I have a vertical line with a circle. It crosses it twice when you draw that vertical line. Therefore, I definitely know that this is not a function. And so we have some more down below. I can see that if I were to draw my vertical line straight up and down, it crosses at most once. So I know that this is definitely going to be a function. And for that second graph, I draw a vertical line and it crosses it once. Therefore, this is definitely going to be a function. And on that last one, that circle, I draw a line and it crosses it twice when I draw that vertical line. Therefore, it is not a function. Okay. So now what we want to do, now that we have our definition of a function, is to evaluate the function. So we want to be careful about what it's asking us to do. So what this is asking us to do is say, hey, here's a function, and here's f of 2. Now evaluate it. So this is saying that x is equal to 2. So what I want to do is I want to find my y value. So, okay, I know that this is really y is equal to x squared plus 3x minus 4. So that x value that I'm going to be plugging in is going to be a positive 2. So when I plug it into my calculator, I'm going to have 2 squared plus 3 times 2 minus 4, and I get that it's going to be equal to a positive 6. So remember, this doesn't say find y to begin with. It started with my function notation of f of 2. So I need to say that f of 2 is equal to 6. And that would be my proper notation. Now, for the second one, what this is saying is, hey, x is equal to a. So it's just switching one variable to the next. So we're just going to switch variables. That's it. We're going to make a clean swap. So, okay, well, I know that y is equal to x squared plus 3x minus 4. But now it's specifically asking us to say it's a. And you're just like, okay. Well, we're switching my x value to an a value. So we are really going to have a squared plus 3a minus 4. So for our proper notation, f of a is equal to a squared plus 3a minus 4. And so that's going to be my answer for f of a. I hope that makes sense. Well, what we're doing now, what this is saying in particular, it says, hey, evaluate h of 4. So again, this is saying that x is equal to 4. So I need to find my y value. So I know that I have y is equal to x squared plus 2x. So the x value that I'm plugging in happens to be 4. So I'm going to get a 16 plus 8. So I'm going to get that y is equal to 24. And to make sure that I write it in my function notation, I'm going to say that h of 4 is equal to 24. And so that's going to be my final answer. Now, you can kind of see the difference between the top example and the bottom example. This one, I specifically have that I have h of 4. Here, I have h of x is equal to 3. So this is slightly different. In particular, this is saying that my y value is 3, and I need to find possible x values. So, okay, here we go. Well, I know that I have y is equal to x squared plus 2x. So the value that I'm plugging in is y, and it's 3. So what I'm going to do is I'm going to subtract 3 from both sides. I want to get it to equal to 0. So from here, I know that I can factor. Well, hopefully you remember that my a is equal to 1, my b is equal to 2, and my c is equal to negative 3. So it's all of these coefficients. And if I need to write it all down, then that's okay. I know that I have a times c, which is a negative 3. My b value is 2. So two numbers to multiply to 3 is 3 and 1. And then to add up to a positive 2, it would be a positive 3 and a negative 1. And positive 3 times negative 1 is a negative 3. Therefore, I know exactly how this is going to factor. So I still have x squared plus 2x minus 3. I did my work, and now I'm going to have that x plus 3 and x minus 1 since I had factored. So I'm going to have x plus 3 is equal to 0. And x is equal to negative 3. X minus 1 is equal to 0, so x is equal to a positive 1. So I have two answers, x is equal to 3, and x is equal to a positive 1. And it was all because of what the question was asking me. It was specifically giving me a y value, and I needed to give them the possible x values. Here, again, it's definitely giving me a y value, and so I'm trying to find my x value. So y is equal to 2. Find x values. So I have y is equal to the square root of x minus 4. that y value that I'm plugging in is 2. And it's equal to the square root of x minus 4. Now, the only way to undo a square is by, or the only way to undo a square root is by squaring both sides. So square and square. So on this side, I'm going to have 4. Now I'll have x minus a 4. To isolate the x, I'm going to add 4 to both sides. When I do this, I get 8 is equal to x. So now I know that my x value is going to be positive 8. Now what they want me to do is to find my values looking at a table. Don't let this n and g of n fool you. What this is really saying is, hey, this is your x value, and that's your y value. So, okay, let's make sense of this. Well, here, is it giving you an x value or a y value? For part A, evaluate g of 3. Hopefully you guessed it. This is saying that x is equal to 3. Find your y value. Well, when x is equal to 3, that's this one. I get my y value is equal to 7. So g of 3 is equal to 7. Now, this part B, it's saying that y is equal to 6. So I need to find the possible x values. Well, I have it here and here. So I'm actually going to have two answers. I'm going to say that x is equal to 2 and x is equal to 4. So we can find it using a table. And hopefully you feel comfortable with that, because now we can do it using a graph as well. So here's our parabola. And it says evaluate f of 2 from the graph. Okay, so I know that x is equal to 2. So I need to find my y value. So remember, here's x and here's y. So along the x-axis, I'm going to find 2, which is here, and I'm going to have the point on the graph. That is 2, 1. So the x is 2, the y value is 1. So now I know that f of 2 is equal to a positive 1. Now for part B, it's saying that y is equal to 4. So I need to find my x values. So, okay, here is 4. And so that value is here. That point corresponds to 3, 4 for the x and the y. And I also have it here. And that point looks like it's -1, 4 for my x and my y. So those 2 points, what they have in common is the y value being 4. So now I can say that x is equal to a -1 and x is equal to a positive 3. Those are going to be my 2 answers there. Now, I want to define a one-to-one function. A one-to-one function is a function in which each output value corresponds to exactly one input value. And if you're like, what in the world is she trying to tell me? It's just saying that my y values don't repeat. So that is going to be our definition for one-to-one. So, looking at the first one, none of our y values are repeating. So don't repeat. Therefore, this is a one-to-one. Over here, we're going to look at our y values again. So y values, and those don't repeat, so this is also 1 to 1. Now over here, the third table, I see a -1 and I see a -1. So the y values here ended up repeating. Therefore, this is not 1 to 1. We can also determine a 1 to 1 by using the horizontal line test. Remember, a horizontal line goes left to right, and I refer to this as the HLT, which is very similar to the vertical line test, which goes up and down, but this horizontal line test goes left to right. So, if I were to draw my horizontal line, which goes left to right, I can see that this graph gets intersected by this horizontal line 3 times. Therefore, I can say that this is not 1 to 1. For my second graph, I draw a line and it crosses it once. Because it crosses it once, I can say that this is not 1 to 1. And here I draw a line for that third graph. It crosses it once, twice. Well, because it crosses it twice, this is definitely not 1 to 1. And I got ahead of myself, didn't I? How many times did that second graph hit? So only crossed once. Therefore, this is 1 to 1. Sorry, I got ahead of myself. Since the horizontal line only crossed the graph once, therefore this is a 1 to 1 function. Okay? The other two are not 1 to 1s because it crossed more than once. The middle one only crossed once, therefore by definition it definitely is a 1 to 1 function. Okay? Alright, down below we just have some common graphs for your reference, and we're going to be referring to those later on. And that is going to be the end for section 3.1. I will start 3.2 in just a minute.